Hello and welcome to the Heart Wielder's Dog Wheelchair tutorial on how to build all of the parts. This tutorial will cover how each of the part was made and how and why each of the features were used. Each of the parts were given a name and number. The J's are the parts that are going to be used for the extendability of the wheelchair, and the K's are the parts that are fixed. And the other labeled parts are different connectors or other things such as the wheels. So to begin with J1, we wanted to model our parts after the PVC pipes that would be used to build our prototype. As you can see, our material is selected as PVC rigid, and here we have our units are in IPS. And the purpose of modeling all of our parts after the PVC pipe was to give a good visual of what our prototype would look like, since we were planning on making it with PVC. So to begin, we start with a sketch on the right plane. The center of the circle is coinciding with the origin and has a diameter of 0.84 inches. From this, we use the boss base extrude feature, and the purpose of this is to make a 3D cylinder from a two-dimensional circle, and the length of this cylinder is 9 inches, and the end condition is mid-plane, and the purpose of this is to create a symmetrical pipe when putting the holes through the pipe, and I will further explain this when I show how the holes were made. Continuing on, we have a single hole made. A center line was drawn such that the circle would be in the center, and the center of this circle was made on the center line. The circle has a diameter of 0.25 inches and is 1 inch from the end of the pipe. Again, the purpose of the center line is to make sure that when we draw the circle with the center on the center line, the circle is in the center of the two sides of the pipe. And the cut extrude feature is used with a through all condition, and this is to make a cut all the way through the pipe, and this is because we want our bolts to be able to go all the way through the pipe and secure the pipe in place. Instead of making holes with the cut extrude feature 7 more times, we use the linear pattern feature, and the purpose of this feature is make it much more convenient, efficient, and less time consuming to put all the holes, the desired holes, onto our pipe. So the way this works is we have a 1 inch spacing in between each of the holes and 8 instances of this. So we have 8 total holes. The right plane is used for the direction, and as I mentioned before, we use the mid-plane feature, or the mid-plane condition when extruding, and this is so that we can use the right plane when patterning as the direction. And this makes it much more convenient and easy to pattern the holes. And the mid-plane end condition allows for this symmetrical pipe to be made. Once the linear pattern is used, we want to hollow out our pipe, so we draw a circle on the base of the cylinder, and this circle is coincident with the center of this circle and is 0.61 inches in diameter. The cut extrude feature is used with the through all condition, and the purpose of this is to make sure we have a fully hollowed out PVC pipe that resembles an actual PVC pipe. Continuing on to J2, this was similarly made. Start out with a circle on the right plane, and the center of the circle is on the origin with 0.48 inches in diameter. The extrude boss base feature is used with 4 inches, and the mid-plane condition is used. From there, we then put a single hole into the pipe. This was made similarly, where we are drawing on the top plane and using the through all condition to make sure the hole goes through the entire pipe. The circle is 0.25 inches in diameter, and this matches the size of our bolts that we will use, and it is 0.25 inches from the end of the pipe. Again, through all condition of cut extrude is used. In this, we linear pattern. This time we have 0.5 inches of spacing in between. There are 8 instances of this, and the right plane again is used to make a nice symmetrical pipe. Last, we want to hollow out our pipe, so we draw a circle with a center coinciding with the center of this circle, and it is 0.61 inches in diameter, and the extrude cut is through all, and that is J2. From this we go to J3. Again, very similarly made. We start with a sketch on the right plane, 0.84 inches in diameter. This circle, has the center of the origin, and this pipe is 4.57 inches in length. The reason for this is this pipe will actually be connecting to the two sides of the frames at the bottom near the wheels, and due to the dimensions of the different pipes, this pipe had to be 4.57 inches in order to be compatible with the rest of the wheelchair. And from that we make this cylinder pipe. We sketch again on the top plane a circle 0.25 inches in diameter, 0.38 inches from the edge of the pipe, and the cut extrude goes all the way through. It is going to be linearly patterned, 0.5 inches of spacing in between 4 instances. And the reason we are using 4 instances is because the length of this pipe was a little odd, as you may recall. And if we were to instance this more times along the pipe, the holes would not be able to line up with the holes that are going to be used to connect this pipe to the rest of the wheelchair. And therefore, because of to fix this, we have it only instanced 4 times. And to make a symmetrical pipe, we use the mirror feature. The mirror feature is able to mirror this linear pattern feature, mirror it about the right plane, and then we get our 4 holes on the other side to make a symmetrical pipe. To reiterate, we had to do this instead of just linearly patterning the entire length of the pipe due to the pipe's somewhat odd length measurement and due to the other dimensions of the wheelchair, such that the holes will line up correctly. And also we want to hollow out the pipe, so we draw the same circle, center coincident with this circle, 0.61 inches in diameter. And the cut extrude through all to make a fully hollowed pipe. Moving on to J4. We start out with, this one was made slightly differently. We start out with a sketch in which we have 2 coincident circles, both coincident to the origin. 0.61 inches is the inner diameter, and 0.84 inches is the outer diameter. And we then extrude this entire sketch, which will automatically create that hollowed circle. It is 8 inches in length. From this, we did this a little differently. The way we do it now is we put a plane above the top plane. It is 0.6575 inches above the, I apologize, the front plane is 0.6575 inches above the front plane. And the purpose of this is then we draw our holes that we want to be made on this plane and then have the through all cut go from this plane all the way through to the other end of the pipe. And here you can see the linear pattern feature was not used, and so each hole was spaced 1 inch from each other, and each hole was made to be 0.25 inches. As you can assume, this took much longer, and that is why the linear pattern feature was used on the other pipes. Once the sketches were made, the cut extrude was used all the way through to make all the way through holes. Moving on to K1. This is the first piece of the fixed pieces that would not be adjusted on the wheelchair. This is a very, very, very simple piece. All it is a sketch. This is on the top plane. Similar dimensions to before. Concentric circles, inner circle diameter 1.32 inches, outer circle diameter 1.03 inches. Let me say that again. Inner circle 1.03 inches in diameter, outer circle 1.32 inches in diameter. And the extrude feature was used, and just blind condition was all that was needed. It's very simple, very fast, and it was 2 inches in length. Moving on to K2. First, we start out with a sketch on the top plane. Inner diameter 1.03 inches, outer diameter 1.32 inches of these concentric circles on the origin. We create a plane on the side of this pipe. It is 0.6575 inches from the front plane. The purpose of this is to then sketch where the holes will be on this plane. This was done manually instead of the linear pattern feature, and the hole, this first hole, is 1 inch away from the edge of the cylinder, and another inch for the second hole, and both circles are 0.25 inches in diameter. The sketch is then extruded, cut, extrude through all to make sure we have a hole that goes all the way through the pipe. Moving on to K3. This pipe was very similarly made. We start out with a sketch on the top plane, similar dimensions as before. Center is the origin. Make another plane, same as before, 0.6575 inches offset from the front plane. This will be so that the plane rests on is tangent to the edge of the pipe. This gives us a good visual of where our holes will be when we sketch on that plane. These holes are made such that they're 0.5 inches in spacing and 0.25 inches in diameter. And again, as they have been for this entire time. They have been drawn on the center line to make sure that they are in the middle of this pipe. Last, we extrude through all to make our holes. Continuing on to K4. Again, a very simple part. Start on the top plane, similar dimensions of before. Center is the origin, concentric circles. And extrude just simply with a blind condition, 1 inch. Moving on to K5. Similar to other pieces that have been made. Start out with a sketch on the top plane, similar dimensions, 1.32 inches outer diameter, 1.03 inches inner diameter, concentric circles, concentric about the origin. We then extrude it. This pipe is 4 inches in length. A blind direction and condition is all that is needed because the patterning is not going to be used, so we can just simply use a blind end condition. Plane is made so we can better visualize holes being placed on the outside of the pipe. That is the purpose of making this plane, 0.6575 inches away from the front plane. Lastly, we sketch on that newly created plane our holes, 1 inch in spacing, 0.25 inches in diameter of these circles. And these circles are then cut extrude through all. Continuing on to K6. Very similarly made. We start out with a sketch on the top plane. Same dimensions, same concentric circles about the origin. This pipe is 1 1/3 inches long with the blind condition. The plane is made 0.6575 inches from the front plane, and this places the plane on the edge of this pipe. We can then draw on this plane the holes that will be made, 0.5 inches in spacing in between them and from the edge of the pipe, and 0.25 inches in diameter. That's the diameter of these circles. From this, we extrude through all. Continuing to K7. Just a simple pipe, same dimensions, concentric circles to the origin, and this pipe is extruded blindly 2.5 inches. Continuing to K8. This is a end cap. We start with a sketch on the right plane. From there, this circle has a diameter of 1.62 inches and has a center on the origin. We then extrude it mid-plane with a length of 0.82825 inches in length. And the purpose of that measurement is to match the actual size of an end cap. From there, we then sketch on one of the faces of the cylinder. to do this, we have just selected this face, and then we are going to make a circle that is concentric with the origin and the same diameter, 1.62 inches. And then from there, from this circle, we will then make a line connecting the centers to make a hemisphere, and then use the trim entities to trim the other side. And the purpose of this is to make a hemisphere from the circle made on the face of this end cap. And so the purpose of making a hemisphere is to then use the revolve feature, and the revolve feature will then make this dome shape. We go blindly 180 degrees to make a blind shape, and we revolve it around the line that we have mated to create the hemisphere from the, a half circle from a circle. And again, the revolve feature is to make this dome shape. From there, we sketch the inner diameter of the end cap. Because it is hollowed out, we sketch on the other face of the pipe, and so we have a diameter of 1.32 inches with center on the origin. We then use the extrude, and we want to do it blindly because we want to go a certain distance, and the distance we go is the distance of the length of the pipe, 0.828125 inches. From there, we can shell the dome so that it is also hollowed out like an actual end cap. So again, the purpose of the shell is to hollow out the dome instead of making a cut. So we have a thickness of 0.1 inch of that shell. And lastly, we want the hole at the end, and this is how the wheel will be connected with an axis or an axle. So we start with a sketch on the right plane, and the reason we could do this is because we will then extrude cut through all, and so it will actually reach all the way to the end of the end cap. And we want to make this a circle with diameter 0.31 inches concentric with the origin. And from this we can then extrude through all. Moving on to K9. This was for the straps of our the strap end caps. This is how the strap will be connected to the wheelchair. We first start out with a sketch on the right plane. This circle is concentric with the origin. It has a diameter of 1.04 inches. And it is extruded .828125 inches mid-plane. Again, we then draw a circle concentric with the origin with diameter 1.04 inches, and then another line will be created across of it to make a half circle, and the trim entities was used to then trim the other half of the circle to make this half circle shown on this sketch. Again, the revolve is used to make this dome shape, blindly 180 degrees, just to make a hemisphere. And the line used to revolve it is that line that separates the circle from the half circle. To continue on, we then sketch on the other face of the cylinder and this is to hollow out the cylinder, so we have a 0.84 inches in diameter circle concentric with the origin, and blindly cut the length of the pipe. From there, we have made a plane just simply on the edge for better visibility, so we could see where we're working, and we then shell the dome to make it hollow like the straight pipe part, and with a shell thickness of 0.1 inch. And afterwards, we can then, on the plane we created, make these two long cuts. The way this was made was using lines and circles and using trim entities to cut away the other halves of the circles to make these rounded parts, and then the lines connect these half circles to make a shape that would fit the straps that would attach a harness to the dog wheelchair. From this, we then extrude through all to make sure it goes all the way through the end of the end cap. And that is how this end cap was created. Moving on to K10. Similar piece to before, we start with a sketch on the top plane. Same dimensions as before, 2 concentric circles with the origin, outer diameter 1.32 inches, inner diameter 1.03 inches. We extrude it a length of 4 inches blindly. We draw a plane to better visualize where our holes, or we create a plane to visualize where our holes will be placed. And this is 0.6575 inches from the front plane. And from there, we make our circles that will be cut. So we have 1 inch of spacing from the end and 0.25 inches in diameter, and they're centered on this center line. And the cut is through all. Moving on to T1, this is one of the connectors. This is an elbow connector. The way this was made was by first sketching on the top plane a circle concentric with the origin that has a radius of 0.66 inches, and a sketch was made on the front plane using circles and lines, and this has a radius of 1.32 inches, this circle piece, and the trim entities was made to trim out the rest of the circle. The dimensions for the lines are shown, and the purpose of making this sketch was because we wanted to use a sweep feature, and to get this elbow shape, it was easy to use the sweep feature where you can use a profile and extrude that profile along a curved path, and that is how we got the curved elbow. So this sketch is the path that we take this circular profile to get our elbow connector. That is shown here. And lastly, all we wanted to do was hollow it out, so we just used the shell with 1.141 inches in thickness. And that is how the elbow connector is made. Moving on to T2, this is a T connector. We first start out with a sketch. This is on the right plane. We then extrude it 3 2/3 inches. We then have another plane made, and the purpose of that is to better visualize where this outwards part will be. And in fact, we will use this plane so that we can extrude downwards into the other plane to get them to have this curvature resembling a T-connector pipe. So this sketch was made on this plane up here. It's 1.32 inches in diameter, with this blind 1.72 inches in length extruded boss base. And that is to get the T-connector shape. Again, the plane was made so we could better visualize where this extension will come from, and it is used to then extrude downwards into this other pipe to get the T-connector shape. From that, we can shell the entire T-connector with 0.141 inches in thickness, and then we simply fillet these two sides to better resemble a T-connector, and they have 0.1 inches of radius. Moving on to our final pieces, we have the wheel. So let us start out. This wheel was based off of the wheel we will be purchasing, and we start out with a sketch on the front plane, 2 concentric circles with the origin. This inner circle has a diameter of 0.5 inches, outer circle has a diameter of 1.2 inches. We then extrude it 0.4 inches blindly, and there we will be adding onto it. We first have our same dimensions of a sketch, and then we then extrude it 1.1 inches in length to get a total length. From there, we make this outer circle. So this was made by sketching on the front plane. We'd have a outer diameter of 5 inches, inner diameter of 4.8 inches. The purpose of making 2 extrude boss base features here was so that we can get one length on one side and another length on the other side of the front plane, as you can see here. And so with this new sketch, we can just extrude it mid-plane to look like the desired wheel, and it is 1 inch. Last, we then create this, we connect it all together with another extruded base. We just do a circle concentric with the origin, inner diameter 1.2 inches, and this will connect it with the axle of the wheel to the rim of the wheel, which has a diameter of 4.8 inches. And this has a depth of 0.25 inches on the inside. So now that we have created the basic shape of the wheel, we can continue developing it. First thing we do is make this nice rounded piece. This is chamfered 0.5 inches with a angle of 45 degrees, and this gets the nice angled wheel, inner rim wheel that we want. From there we make a plane that is 0.25 inches from the face of the wheel. Afterwards, we make the design of these spokes of the wheel. These are made with the line tool, and the purpose of the plane before was so that we can sketch on that plane and then extrude inwards. And the dimensions for all of this are shown. So we then extrude what we have made on the plane we had created. That was the purpose of the plane. We extrude 0.25 inches blindly to get the desired depth that we want, and then we have nice spokes on our wheel. We then fillet those to make them better looking with 0.1 inches in radius, and from that we make another plane, this time coincident with the face, and it's just to get a good reference. We then chamfer again 0.4 inches in distance at an angle of 45 degrees to get the nice angled wheel look on the rim. From that, we then make the spokes of the other side of the wheel, which you will see get circularly patterned, which would be very time consuming to make all of those. So for that reason, we make the simple pattern and then get that patterned around the wheel. So this was made using the line tool on that plane we had created before. That was the purpose of that plane, and the dimensions for this are shown here. The purpose of the circular pattern is to make sure to save time and not having to put the spokes everywhere around the wheel. We have 10 instances with spacing of 36 degrees, and a direction is this edge here. We then fillet those to make them better looking with 0.3 inches in radius. We then make another sketch, similar dimensions to before where we were making the wheel. And the purpose of that sketch is to then use the cut extrude to make this notch in the wheel, and the purpose of that is because the tire will actually be able to fit in this notch that we have created. So this sketch has the same dimensions as the outer wheel, 4.8 inches diameter, 5 inches outer diameter, and then the cut extrude is used to make the rim, and it is a 0.5 inch depth. We continue with another plane at the top. This plane is 2.4 inches from the top plane. We make a sketch on that plane. here it's a center line with 0.25 inches from the inner rims, and then we simply at the very end fillet the outside of the wheel to make it nice, and with 0.025 inches of fillet. Continuing on, we have the tires piece. This was made with similar dimensions to the wheel, 4.8 inches in inner diameter and 5 inches in outer diameter of these two concentric circles to the origin. Then extrude that 0.5 inches. From there, we make another sketch, two concentric circles with the origin, 5 inches inner diameter, 6 inches outer diameter. So as you can see, we have widened the wheel. We then fillet it on the inside, 0.025 inches. Filleted more, 0.05 inches. And we have another plane. And lastly, another sketch. And the purpose of the plane in sketches seen in both the tire and the wheel is so that they can be aligned later in the assembly. Lastly, we have just a connector piece that is used to connect certain PVC pipes. We start out with a circle diameter 1.66 inches, concentric with the origin. We extrude that 2.125 inches mid-plane. Lastly, we do another sketch to hollow out this pipe, 1.41 inches diameter, concentric with the origin. Use cut extrude through all to make it a completely hollow pipe. And that is how the connector is made. And this is the end of the parts tutorial.